This is the video of the review sheet for Algebra 1 with lab for the first test. So number 1 says, what is the value of the expression absolute value of negative 5x plus 12 when x is equal to 5? So the first thing that you do is we're going to take 5 and evaluate, substitute that in for x. But when I do this, I must use parentheses. So I'm writing, instead of an x, I'm putting parentheses, and I'm going to place the number that we are substituting for x directly in the parentheses. Now in this problem it doesn't matter so much, but in other problems it can. Then I will follow order of operations, or PEMDAS. So I look inside the parentheses, and there's just a 5. Nothing to do. But then I notice I have my absolute value bars, which act as a parenthesis, so I must do what's inside those absolute value bars. So I must follow order of operations inside the absolute value bars. There are no exponents, so I will cross that off the list. And now I'm looking only inside of the absolute value bar. Inside the absolute value bars. So I'm only looking at this. And now I will look for any multiplication or division problems, and I will do them from left to right. And lo and behold, I have negative 5 times 5, which is negative 25. And I will write everything else as I still see it. So I will bring down the absolute value bars. I will bring down the 12. So we have the absolute value of negative 25 plus 12. I must continue to do what is inside the absolute value bars. I'm not taking an absolute value of any number yet, because I still have work to do inside of the absolute value bars. So we now have to add or subtract inside those absolute value bars, and we can. Negative 25 plus 12 is negative 13. So there's my result. I still have the absolute value bars. And now, since I have a single number inside of the absolute value bars, I am ready to take the absolute value of whatever's in there. The absolute value of negative 13 is positive 13. So we have choice B. Let me just quickly remind you, this is a reminder. The absolute value of a negative number is the positive version of that number, or the opposite. But the absolute value of a positive number is just the number. Okay? So this is important in case on the quiz or the test tomorrow that I asked you the absolute value of a positive number. Don't make it negative. You just keep the number that you had. All right, so number 2 says, which property is illustrated by the equation ax plus ay equals a times, in parentheses, x plus y? You're used to looking at this the other way. You're used to kind of looking at this part first. And if you notice, if I had a parentheses x plus y, I would distribute the a to get ax plus ay. That is the distributive property. Number 3 says, which verbal expression represents 2 times, in parentheses, n minus 4? I'm going to translate each of these, even if they're not the right answer. So A says twice n minus 4. Twice something means to multiply it by 2 minus 4. Minus gets translated as you read it. So twice n comes first, then 4 comes last. That's not what we have because the parentheses are missing. So that is not the correct choice. So B says twice the quantity. The quantity is a signal for us that something in parentheses is going to come. So I have twice the quantity. We'll open up in parentheses, and whatever comes after the word quantity is going to go in those parentheses. N less than 4. So important. Less than. Less than gets translated backwards. For example, if I said to you, I want 5 less than 9, I have to have this number first. I want 5 less than whatever this is. So I want 9 minus 5. So when I translate n less than 4, the 4 comes first, and then I will subtract the n. Really, really, really important. Everybody always messes this up. That is not the answer. Because the one they wanted me to translate says n minus 4. So B is not the answer. C, twice 4 decreased by n. Well, twice 4 is 2 times 4. But then I'm decreasing it by n. If I decrease, so for example, if I said 9 decreased by 5, that would just be a plain old 9 minus 5. So decreased by gets translated in the order that you read it in. So I'm going to decrease this by n. Clearly not the answer. D says twice the quantity, parentheses, 4 less than n. 4 less than n gets translated backwards. So the n gets to go first this time, and the 4 gets to go last. And that is exactly what's matched up with what they wanted. So choice D is the answer. So 3 is D. Number 4, what is the solution of the equation 3y minus 5y plus 10 equals 36? I need to combine like terms. This is my analogy. When you go home and you want to go out for the night, you want to hang out at your friend's house, what does your mom and dad say before you go? You got to clean your room. You have to clean up both sides of the equation before you start moving anywhere. So you got to stay home and clean your room before you get to go to your friend's house. That's kind of the analogy. And by the way, I'm going to draw just a little dotted line to separate one side of the equation from the other. I have like terms. I have my 3y and negative 5y on the left-hand side. 3y minus 5y is negative 2y. All we did was we took the coefficients, the numbers in front, and did what they told us to do, subtract them. Plus 10 equals 36. You want to get y by itself, so I will subtract 10 from both sides. I have negative 2y. These 10s and negative 10 become 0, so effectively they, quote, cancel, equals 26. And I will divide by negative 2 on both sides, because negative 2 and y are being multiplied together. And 26 divided by negative 2 is negative 13. And the negative 2's divide and become a 1. And 1 times y is just y. So y is negative 13. Choice A. Number 5, what is the first step in evaluating the expression 2 parentheses 5 times 6 squared? If I use PEMDAS, PEMDAS says I must do what's in parentheses first. So inside the parentheses, I have a problem to do. It's 5 times 6. That would be my first step. So I realize I accidentally typed the correct answer twice, so you could have had A or D. Number 7. Nope, no, sorry, number 6. Associative property. Okay? So, associative property. Here's the deal, right? To associate. That word associate kind of means loosely to hang out with. To hang out or be with. That's what it means in real life. If I say Gianna is associating with Liz, that means Liz and Gianna are hanging out together. All right? So, the associative property means that if 2 and 3 are hanging out together and 4 is not with them, that's the same thing, if you add, as if I had 2 not hanging out, but 3 and 4 were in the parentheses together. So what I'm saying is 2 and 3 are associating with each other on the left. 3 and 4 are associating with each other on the right. But at the end of the day, if I were to do both sides of this equation, I would get the same answer. So for example, 2 plus 3 is 5. I would do what's in parentheses first. And then 5 plus 4 is just 9. On the right-hand side, I would do the 3 plus 4 first, which is 7. And 2 plus 7 is 9. And 9 equals 9. That's the associative property. What's so critical is that two different people or two different numbers are in the parentheses on both sides. That's what's so critical. So if we look at A has no association. There's no one hanging out in parentheses. Choice C also has no parentheses. Choice B has a parentheses on one side, but if you look, what I've done here is we've distributed the x to both the y and the z. So that's the distributive property. So last but not least is D. If you look, I have x plus y in one parentheses, and on the other side we have y plus z. So two different people or two different variables or two different numbers are associating with each other on one side versus the other side of the equation. Number 7. Which verbal expression is represented by 2x minus 10? And I want to do the same thing. I'm going to translate all 4 of these. 10 less than 2 times a number. Less than gets translated backwards. So less than gets translated backwards from how you read it. So 10 less than 2 times a number. The 2 times a number part goes first. So 2n, or I'll use x because that's what the problem is using. 2x goes first, minus 10. That's the answer. But since we're doing a video lesson, we'll do all the choices. B, 2 times a number less than 10. This could be translated really 2 ways. Here's one way. And I wouldn't ask you anything ambiguous like that or on the test. 2 times a number is 2x. Less than 10 is 10. But I want to switch this. So I'm saying 2 times a number less than 10. So less than means to switch the order. So I would do 10 minus 2x. That's no good. C says 2 times a number, which is 2x again, but it's increased by 10. Increased means I'm adding 10. If I increase, if I said, all right, you got an 80, and then I increased your test score by 5 points, you would have an 85. I'm adding. That's no good. And D says 10 minus triple a number. Minus gets translated as you read it. So I'm reading 10 minus triple a number is 3 times that number, or 3x. And that's clearly not 2x minus 10. Number 8. What is the multiplicative inverse of 3 over 4? What you have to know, the multiplicative inverse means take the reciprocal. So, what is a reciprocal? Well, for example, 4/5, its reciprocal is 5 over 4. 9/10, its reciprocal is 10/9, or 10 over 9. Negative 2 over 3, its reciprocal is negative 3 over 2. You do not change the sign. So if you wanted a simple rule for this, you flip the fraction and do not change the sign. So the multiplicative inverse is another word for reciprocal. And I want the reciprocal of 3 over 4. That is 4 over 3. You know the reciprocal, by the way. Let me just say, like, if you were solving 2 over 3x equals 6, you know to multiply by the reciprocal. to solve this, which is 3 over 2. And this is because 3 times 2 is a 6, 2 times 3 is a 6, and 6 divided by 6 is 1. So what happens is these guys cancel and become a 1. And 1 times x is just x. That's why they're called multiplicative inverses. Inverses cancel. Inverse is another way of kind of saying the opposite operation. And then 6 times 3 is 18, divided by 2 is 9. So that's just a side note. You know reciprocals. Think about when you're solving an equation with a fraction in front of the variable. All right, number 9 says, what is the additive inverse? The additive inverse is just another way to say opposite, which means change the sign, but don't flip. So it's like, basically, the reciprocal is flip, but don't change the sign. The opposite is change the sign, but don't flip. So the opposite of 3 over 4, I just change the sign. If I look at a number and don't see a sign, it's positive. Now I'm going to make that positive number into negative. Notice I did not change the numbers. I just changed the sign. I didn't change the place where the 4 and the 3 are. So the answer is negative 3/4. You're either doing one or the other. You're changing the sign or you're flipping, depending on whether it says additive inverse or whether it says multiplicative inverse. Number 10, if t equals negative 3, then 3t squared plus 5t plus 6 equals. Here's another one. We are plugging in a number for a letter. So when I do this, I'm going to use parentheses. So instead of writing the letter, I'm going to write parentheses. Notice I put the square on the outside of the parentheses. That's always something that people forget. They try to put it inside. I don't do that. I just write a set of parentheses. And that number, negative 3, will go in there in a second. So plus 5 times, I'm going to write myself a parentheses to represent that t, plus 6. So everything in blue was in the original expression. And the red is me just saying instead of a t, I'm putting parentheses. Now I'm ready to take the negative 3 and put it inside the parentheses. Now I have this nice and set up. And now I follow order of operations. I have 2 sets of parentheses, but I look inside and I say there's really nothing to do. So while the parentheses are there, there's nothing to do inside of them. So we can move on to exponents. I have my exponent right here. So I need to apply that to all of negative 3. So negative 3 squared, you can do this on your calculator, or you can say, well, that's negative 3 times negative 3. A negative times a negative is a positive. So this is now positive 9. So this whole red parentheses gets replaced by a 9. Now here's something that people forget. I had 3 times the red stuff. So I still have 3 times 9. Or if you want, if you feel like you took care of the parentheses, you can say 3 times 9 like that. Plus 5 times negative 3 plus 6. No more exponents, I just did it. Now we look for multiplication and division from left to right. Well, I have my 3 times 9. That's 27. I still have another multiplication problem to do. It's 5 times negative 3, which is negative 15. So I can write that as plus negative 15, or I can write it as minus 15. It doesn't matter. I'm actually going to write it as minus 15. I think that's easier for most people to understand. I have a positive times a negative, which gives me a negative, which makes me subtract 15. Notice there's only one negative sign. I'm not subtracting negative 15. And now I have addition and subtraction that I must do from left to right. So that's kind of the way you read. So if I start from the left, I have 27 minus 15. That comes first. 27 minus 15 is 12. Bring down my plus 6. And 12 plus 6 is 18. So 18 is the final answer, choice D. Number 11. What is the first step in simplifying this expression? 2 minus 3 times 4 plus 5, all in parentheses, and I square. So again, using order of operations. I look inside the parentheses. Look inside, and boy, do I see a lot of stuff going on. So inside the parentheses is where I'm looking. I'm only looking at the yellow. Now I look inside and I say, are there any exponents? And there are none. So I go to my next check, multiplication and division. Are there any multiplication or division problems? And there absolutely is. In the middle is 3 times 4. So that would be my first step. So multiply by 3 by 4 is the first step. Where people would do this is they would say, well, maybe I have to square because exponents comes before multiplication. However, it's what's inside that parentheses that I have to look at first. So the square, the exponent is outside of the parentheses. So I ignore that until I deal with what's in the parentheses first. All right, number 12 says, which property is illustrated by the equation 3 over 2x plus 0 equals 3 over 2x? Well, first of all, I'm adding. We're adding. So guess what? Anything that doesn't say adding is out. Now, unfortunately, the only choice that doesn't say anything about adding is the distributive property. And I hope you see there aren't any parentheses in this equation. The distributive property is out. Now, commutative property. Commutative property is, I use this analogy. Your parents commute to work. They go from home to work and then work to home. And if I think of this as a little like baby equation, this would be the commutative property. So to commute means you switch your location. You go from home to work, work to home. That's not what's happening here. I don't see a switch, so it's out. Now, additive inverse versus additive identity. The additive identity is what do I add to a number to reveal the identity? So imagine for a minute, okay, I took, okay, I want to make this smiley big and you'll see what I'm doing in a second. Here's my smiley, okay. If I take smiley and add 0 to it, I just get smiley. Adding 0 revealed the identity of what I had. So for example, okay, imagine, and I want to pause the video for a minute because I'm going to set this up. All right, now I have this set up. So I have something underneath my scribble plus 0, and that equals star. Well, something underneath my scribble plus 0, so whatever I'm adding to what underneath the scribble equals star. Well, guess what? If I'm adding 0 to something and I get a quantity, the original thing had to be that quantity or the star. So imagine it this. So I want to cover this back up. Pause. If I had this situation with numbers, something covered up plus 0 equals 7. Well, I know that the covered up thing has to be a 7 because 7 plus 0 equals 7. So the whole idea is that adding 0 reveals the identity of the covered up blob. Whoops. Nope, didn't want to do that. This adding 0 reveals the identity of the covered up blob. So it's the identity property. Anytime you have the same thing here and there, it's the identity. Here I have 3/2 x plus 0 equals 3/2 x. Adding 0 has revealed the identity or verified the identity of what was there originally. Inverses are when I take numbers. So for example, if I take -3 and add it to its opposite, which is 3, When I take inverses and add them together, I get 0. I get the identity. These guys are the inverses. So this would be an example of the additive inverse property. But when I'm adding 0 to get an answer, it's the identity property. All right, number 13. The additive inverse of 1 over a is additive inverse means take the opposite. The opposite means change the sign. So 1 over a, I don't see a sign. I understand that number to be positive. Its additive inverse is the negative version of that number, or negative 1 over a. All right, number 14 says, what is the value of x in the equation 13x minus 2 parentheses x plus 4 equals 8x plus 1? So like I said, you need to clean your room before you get to go out and move around and go to places. Same thing. I have to clean up the left-hand side before I move anything around. So the first thing I'll do is, I don't like these parentheses. I can use the distributive property and distribute to the negative 2. The 13x comes down. I get negative 2 times x, which is negative 2x, and negative 2 times a positive 4, which is negative 8. And that equals 8x plus 1. Now, I'm still not done cleaning up. This is like when you clean up half your room and your mom comes in and she says, well, how about making the bed? And how about straightening up your dresser? And how about maybe doing a little dusting? We still have to clean up this left-hand side. I have my like terms, my 13x and the negative 2x. They're like terms because they have the same variable. It's x. So 13x minus 2x is 11x. Now I have cleaned up both sides. There are no like terms on the left. There are no like terms on the right. And now we can start moving. Now you can go out with your friends. We can start moving some terms around the other side. So I want to get all my x's to one side. So I'm going to subtract 8x because I'd like to remove that from the left-hand side. And I'll bring it over to the right. So this side will be my x's, and the other side will be my numbers. That's the whole idea. You want to get all the x's to one side, all the numbers to the other. So the 8x's add up to 0. They're additive inverses. 11x minus 8x is 3x. 3x minus 8 equals, well, what's left over on the right-hand side? Just the 1. Just this 1. Okay, I have x's and numbers on the left, but I just want x's. So I will add 8 to both sides. You're doing the opposite of what's there. Negative 8 plus positive 8 is 0, which means they, quote, cancel. I would get 3x left equals 1 plus 8 is 9. 3x equals 9. Divide by 3 on both sides. And x is equal to 9 divided by 3, which is 3. And so choice C is 3. Number 15. Which equation illustrates the multiplicative identity element? So again, I'm going to pause the video. So I wrote a little problem. I have blah, or mystery number, plus times 1 equals 8. Well, if I'm multiplying by 1 and I get 8, the mystery number had to be 8. 8 times 1 is the only thing that gives you 8. So by multiplying by 1, it would very easily reveal the identity of what was the blob or the mystery number. So when I multiply by 1, I'm revealing the identity of what was originally the number. So I have to look at where I'm multiplying by 1. A and B I am not multiplying. They are nonsense. C, I'm not multiplying by 1. I'm multiplying by 1 over x. That's not the answer. D is I'm multiplying x by 1 and I'm getting x. This multiplication reveals the identity of the mystery value or variable. That's choice D. Choice C would be when I'm multiplying reciprocals, because x is really x over 1 times 1 over x, and that equals 1. This would be the inverse property, or the multiplicative inverse. I see reciprocals. Okay? All right, number 16 is another evaluation question. If x equals -4 and y equals 3, what is the value of x minus 3y squared? So first things first, whenever I plug in a number for a letter, I use parentheses. So I'm going to use parentheses around my x, minus 3, and I'm going to use parentheses for the y, and the squared goes outside the parentheses. And now I will fill in my numbers. X was -4. Boop. Y was 3. Boop. And I could type this on the calculator, or I can use order of operations. I'll use order of operations because we need practice with that. So again, back to PEMDAS. I look inside the parentheses, -4, 3. Nothing to do inside. Then I do my exponents. I have my squared exponent. So I need to do 3 squared. 3 squared is 9. So I have -4, which I won't write with parentheses anymore because there was nothing to do, minus 3 times, because that's what these outer parentheses meant with respect to the 3, the red 3 and the green 3. 3 times 9. Okay, so I took care of the exponents. Now I look for any multiplication or division problem from left to right. Again, we go from left to right. So I have, well, -4 minus 3 times 9. There's my multiplication problem, which is 27. So I have -4 minus the 27 we just got from doing the 3 times 9. And now we have one thing left to do. -4 minus 27. You can do this on your calculator. I encourage you to do that. But if you're trying to do it in your head, understand. Imagine you were playing football. Negative means you lost yards. You lost 4 yards. And then you lost another 27. Altogether, you lost, which is negative, 31. Okay? Another way to look at it is on a number line. So here's 0. -4 is to the left. I'm going another -27. So I'm moving to the left, 27. I would be at -31. Okay? So -31 is the answer, choice C. Number 17. 20 more than 4 times a number is 64. Find the number. The first thing that I teach you guys to do is look for the equal sign. The equal sign is right here. That's the is. And it is, something is 64. Then I have 20 more than 4 times a number. 20 more than means I will add 20 to 4 times a number, and I'll call the number x. And now I just have to solve this equation. Subtract 20 on both sides. I get 4x equals 44. And divide by 4, and x is 11. That was a good one. Number 18. Twice a number decreased by 5 is 11. Is the equal sign. 11 comes after. Twice a number decreased by 5. Decreased by gets translated how you read it. Decreased means a subtraction, but it gets done in the order in which you read it. So twice a number, 2x, minus 5 equals 11. Add 5 on both sides. I get 2x equals 16. Divide by 2 on both sides. X equals 8. That's your number. Number 19. 24 less than 4 times a number is 48. There's my equal sign. Now, 24 less than, we have to remember, this has come up quite a few times, less than gets translated backwards. So the 24 less than 4 times a number, the 4 times a number has to go first. So 4x less than minus 24 equals 48. And now we'll just do our regular algebra steps. So we'll add 24 to both sides. 4x, these cancel, equals 72. Divided by 4. And x equals, it happens to be 18. Number 20 says, if 5 is subtracted from triple a number, the result is 13. The result is your equal sign. So there's my equal sign. I'm equaling 13. If 5 is subtracted from triple a number, we said when we translate the word from must go first. The from must go first. So I take 5 subtracted from triple a number. So what comes after the from goes first. So triple the number goes first. So after the from, whatever there is goes first. Think of from begins with an F. First begins with an F. Minus, well, what was I subtracting? My 5. Add 5 to both sides. We get 3n equals 18 divided by 3, n equals 6. Next question, 21. Find a number such that 2 times the quantity of 4 less than the number is 10. You find that equal sign. That's the is. Equals 10. Now you want to translate what's behind that. 2 times the quantity of 4 less than a number. 2 times, I like a 2, the quantity tells me I need to use a parentheses. I want to open up a big parentheses because whatever comes after it, I have to put inside the parentheses. So this whole thing is going inside parentheses. It's going inside the parentheses. 4 less than the number. We have to remember, less than gets translated backwards. 4 less than the number. So 4 less than the number, the unknown goes first, so that's my x, minus 4. And now I have my translation. Now we can solve this equation. I have parentheses, I'm distributing. So we get 2x minus 8 equals 10. Add 8 to both sides. I have 2x equals 18 divided by 2, and x is 9. All right, number 22. Again, I'm going to look for my equal sign, which is important in this problem. 1/2 of 8 less than the number is equal to, stop reading. Right here is my equal sign. And then I have lots of stuff after that. 10 subtracted from the number. I'm going to split this up into a before the equal sign. So here's my thing before the equal sign. Whoops. And then I'm going to highlight in blue the stuff after the equal sign. So before the equal sign, the stuff that's in yellow. 1/2 of 8 less than a number of, in this case, it's 1/2 of lots of stuff coming after it. So we need parentheses. It's 1/2 of 8 less than a number is n minus 8. Again, less than gets translated backwards, is equal to 10 subtracted from the number. Whatever comes after the from goes first. So the number goes first, minus 10. And I actually use n for the number. I got to use n on the right side. So number 22, I will distribute. 1/2 times n is 1/2 n. 1/2 times negative 8, if you do that on your calculator, I suggest you do, is negative 4 equals n minus 10. And this is really 1n minus 10. Now I have to move my numbers to one side and my letters to the other. I will subtract the 1/2 n, and so I'll make this the letter side. So I want to subtract 1/2 n from both sides. So this will cancel, and I'll get negative 4 equals 1n minus 1/2 n. If someone has $1 and takes away 50 cents, or you spend 50 cents, that's half a dollar, you have half left. So that would be 1/2 n minus 10. I'll add 10 on both sides to get rid of it from the letter. And so I have negative 4 plus 10 equals 6. 6 equals 1/2 n. And then to get rid of a fraction being multiplied by the variable, we multiply by the reciprocal. So by 2/1 on both sides. That's your multiplicative inverse, basically. So the 2's cancel, the 1's cancel. And we get n equals 2/1 times 6, which is 12. Do the calculator arithmetic. Do the fractions on your calculator. All right. Press the green key, and then y equals, and you press enter. Number 23 says solve for L. V equals LWH. My hint for you with all the equations with letters was to box in the letter. And if you're not quite sure what to do, plug in numbers for W and H. So for example, and I'm going to erase this eventually, but okay, let's say V, instead of V being a V, because we want to solve for L, so I'm going to leave the L alone. But let's say the V was a 30. The L I'm going to leave alone, times, because it's a letter next to a letter, without anything in between. W, let's say, is a 3. And H is a 2. Okay? Well, I can do 3 times 2 here, which is 6. So I get 30 equals L times 6. And I would divide by 6 because that's the opposite of what I'm seeing. And L would be 5. The key is I'm dividing by the 3 times 2, which became a 6. I'm just dividing by that, by these guys, the 3 times 2. So now I'm going to erase, and we're going to go back to the original equation. I have V equals LWH. These are connected by multiplication. To get rid of them, I will divide by WH. These W's cancel, the H's cancel. And I'm so happy because L is by itself equals V over WH. Done. There's my answer. I'll box it in like that. Number 24 says solve for Y. 2x minus 3y equals 8. Again, if you box your y in because you're being asked to solve for y, and then again, if you're not sure what to do, you plug in numbers for the other letters. So for example, I'll make x 4. No, let me not make x 4. I'll make x 6. So if I made x 6, 2 times 6 is 12. So instead of the 2x, I'm putting a 12. That's the only change I'm making. Minus 3y equals 8. Well, you know what the first move would be with the numbers. I would have to subtract 12 from both sides. Those would go away, and I would be left with, this is where people mess this up, I would be left with negative 3y. The 12 minus 12 became 0, had nothing to do with this sign. Equals 8 minus 12, which is negative 4. And then I would divide by -3. Okay? So if I were listing the steps, I first subtracted the 12, and then I divided by -3. Those are my steps. I don't even care what the answer is. But instead of the 12, I have the 2x. So I'm going to subtract, not the 12, but the guy who was in the 12's place, which is just the 2x. So we'll subtract 2x from both sides of the equation. This 2x will cancel with that 2x. And now we have -3y equals, I can't combine 8 and 2x. They're not like terms. I don't have to. I can just write 8 minus 2x. Now I still don't have y by itself. It's connected by multiplication to a -3. So I will divide by -3. And y equals 8 minus 2x divided by -3, which for now is totally acceptable. We will make that nicer as we go on later in the year. But that's fine for now. 25 says solve for y. I have a equals x plus y all divided by 2. Now, if you remember, if I asked you to evaluate 6 plus 4 divided by 2, the fraction bar traps the 6 plus 4 kind of in a parentheses. So I have to find that numerator first, which is 10 divided by 2, which is 5. I can't just do much to the y because it's trapped by the fraction. But the fraction means division. So when I'm dividing here, when I have this fraction here, I'm dividing by 2. In order to untrap or undo division by 2, I must multiply by 2. So I will multiply by 2 on the right and do the same thing on the left. These 2's will divide, and the fraction will be gone now. So we have 2a equals x plus y. Y is not by itself yet. It's being bothered by being added by x. So how do I undo being added by x? I do the opposite. What's the opposite of addition? Well, it's subtraction. So subtract x from both sides. These x's will become 0, and they will wipe out. And I will get y on the right equals, well, I just have 2a minus x. Done. Voila. There it is. Number 26 says, number 26 is a word problem in some respect. It says, shoe sizes and foot length are related by the formula S equals 3F minus 24, where S represents the shoe size. So I'm just going to write that down on the side. And F represents the length of the foot. Length of foot. Okay? In inches. It says find an expression for the length of the foot in terms of shoe size. It says, if you kind of delete an expression for, it says find the length of the foot. Or solve for the length of the foot. That's another way to say the question. I want to solve this equation for F in terms of shoe size, meaning the answer is going to be something with shoe size in it, or an S. So I'm expecting there to be an S in my answer. So now I think about this for a minute. I say, imagine if the S was an 18. What would my first step be in solving the black equation I just wrote? We would add 24 to both sides. So you know what? I'm just going to take this all aside now. Let me just get this out of the way so I can make some room here. Here we go. I'm just going to make this a little smaller. Okay. Instead of having the S there, I put an 18. But this is the same exact thing. I will add 24 to both sides. In the black equation, I can make that into a number. I can make that 42 equals 3f. In the blue, I can't, but I don't care. It just becomes s plus 24 equals 3 times f. In the black equation, I would divide by 3. So in the blue equation, to get rid of the 3 multiplying by the f, I'll divide by 3. I need a long, big fraction bar, and so f is just s plus 24 divided by 3. There's my final answer. Remember, these 3's cancel. All right, 27 says solve for g. Negative 5 over 4g minus 7 equals 23. And again, if you're having trouble with this, imagine it was negative 2g minus 7 equals 23 for a minute. Imagine the fraction was a nice number. What will we do first? Well, I would add 7 to both sides. That's what we'll do over here. Adding 7 to both sides of the equation. These 7's go away. I'm left with negative 5 over 4g equals 23 plus 7 is 30. Now, whenever there's a fraction in front of a letter, we multiply by the reciprocal. The reciprocal means I just take the numbers that I see, the 5 and the 4, I swap them, but I keep the same sign. Reciprocals or multiplicative inverses, you don't change the sign. So now, what happens here, the 4's divide out. The 5's divide out. And what's a negative times a negative? Well, negative times a negative is a positive. So I'm really left with positive 1 after we multiplied those fractions. And I'm left with g, essentially, because 1 times g is g. G is now by itself. 30 times negative 4 over 5. Let me just pull up the calculator, and I will show you how to do this on the calculator in case you forgot. And, whoops, here's how we do this on the calculator. Let me just X that out. I'm sorry, I'm having some technical issues with the calculator. So you can do this the old-fashioned way by multiplying across from left to right. 30 times negative 4 is negative 120. 1 times 5 is 5. And negative 120 divided by 5 is negative 24. So g is negative 24. All right, 2 more problems. Solve for x. So I have lots of parentheses I need to distribute. So I have 5 times 2x is 10x. 5 times negative 6 is negative 30. Then I have to distribute over here. Negative 3 times 2 is negative 6. Negative 3 times negative x is positive x. Again, we need to clean up the left-hand side. I have 10x, and I have my 1x. So that's 11x. I have negative 30 minus 6, which is negative 36, equals 2x minus 3. Now we have everything cleaned up on both sides. Now we can move stuff. So we'll subtract 2x. We get 9x minus 36 equals negative 3. Add 36 to both sides. And then we end up with 9x equals 33. All right, I made a boo-boo because I'm getting into 55 minutes on this video. So when I do negative 3 times negative x up here, it should be negative 3x. Sorry, positive 3x. So we have minus 6 plus 3x, which makes 10x plus 3x become 13x. See how I'm correcting myself? This isn't such a bad thing to happen in a movie here. And then I have 13x minus 2x instead of 11x minus 2x, which is 11x. And now I have, that's much better. Now I have 11x equals 33. I saw that we were going to get a decimal, and this problem does not result in a decimal. Divided by 11, and x is 3, or x equals 3. One more. That's kind of funny that we're doing this because this problem is going to show us. So Elise solves the equation negative 2 times 4 minus 2x minus 16 equals 8x. I have to distribute. So I have negative 2 times 4 is negative 8. And I have negative 2 times negative 2x, which is positive 4x. If you notice, Elise had negative 4x. So is Elise's solution correct? No. Elise's solution is not correct. Identify what the mistake was. So Elise did not distribute properly. In step 1. And now we have to correct the problem. So I have to combine my like terms on the left side where I have negative 8 minus 16. So that's negative 24. So we have 4x minus 24 equals 8x. Subtract 4x on both sides. So we have negative 24 equals 4x divided by 4. And x equals negative 6. And now we are done.